Hey there, it's Mr. Allred for Calculus class, and here's another optimization example. So, the things we've kind of figured out up to this point are that we are given some measurement that we can create a formula for, and then we're trying to maximize or minimize another characteristic based off of those restrictions. So usually we see two equations, and one of those is the one we want to take the derivative of, and we'll use the other one to help us get our function in one variable. So let's read this one. It says a metal can with a volume of, so that's volume of 60 inches cubed. So down here, volume equals 60 inches cubed. And in the middle, we were already given the formula for the volume of a cylinder. If you don't know that, you can always look it up, but it's pi r squared h. Okay? So that's the radius squared times the height times pi. It is to be constructed in the shape of a right circular cylinder. Okay? If the cost of the material for the sides is a nickel per square inch, and the cost of the material for the top and the bottom is 3 cents per square inch, find the dimensions of the can that will minimize the cost. So here we're trying to build a cost formula. So we're told that the sides of the cylinder are going to cost 5 cents per square inch. So over here is that 5 cents. Now, what's the side? Well, just kind of think about this for a second. If I took this can and I cut it down the side and I unrolled it, it would just be a rectangle. Well, that rectangle has a height, and the length of that rectangle would be the circumference of the bottom. So that's the 2 pi r. So the area of that would be, I wrote it wrong, but I said it right. 2 pi r. So the area of the sides would be the area of that rectangle, 2 pi r h. And that's what we have over here. That's the area of the sides times the 5 cents per square inch. Okay. And then the top and the bottom. The top and the bottom are just circles. Okay. So the top and the bottom are just circles. Well, the area of a circle is pi r squared. Okay, so looking at the formula we got here, we've got pi r squared. There's a top and a bottom, so that's two of them, and then 3 cents per square inch. So that's where the cost formula comes from. You can kind of look up the surface area, which is basically what we have here. It won't have the 3 cents and the 5 cents with it, but if you're trying to figure out what makes this cylinder up, it is basically the surface area, but different parts of the cylinder cost different amounts to make. Okay? So what we're trying to do is we're trying to minimize the cost. So that's the one we want to take the derivative of. So that's the one we want to work with. We want to work with the cost. Okay, but the cost has two main variables in it, r and h. And I'll say there's more r's in here than h's. So let's use the volume formula here, which will be 60 equals pi r squared h. And let's get h by itself so we can keep all the r's in there. So h would be 60 over pi r squared. And I'll rewrite that just a little bit to make the substitution. Hopefully we can keep this all on one page. But the height, another way to write that would be 60 over pi. We'll bring the r squared up to the top, r to the negative 2. And I only do that so that when I plug everything in, I'm going to want all of that on the top. So this is the substitution I'm going to use. So let's see. Let's say our cost formula. And let's just go ahead and say the 3 cent times the 2 will be 6 cent. That'll save us a little bit of writing. Pi r squared. Okay, so that was already all in terms of r. Okay, then the other one here, the 2 times the 5 cent, that'll be 10 cents, so 0.1 pi r, part of the formula, and what I want to replace is the h, and I'm going to have to replace it with 60 over pi r to the negative 2. So I definitely need to clean this up. Okay, so c equals 0.06 pi r squared for the top and bottom, plus, let's see here, 60 times 0.1 will be 6, and then we will have a pi on top, a pi on the bottom that'll cancel out, and then r times r to the negative 2 will be r to the negative 1. Okay, so I wrote my cost function in terms of one variable, which in this case was r, and I've cleaned it up, and I want to minimize that, so let's take the derivative. Okay, so now let's take the derivative. Okay, so we're just using power rules here, so we'll have 0.12 pi r minus 6r to the negative 2. And because we want to minimize that, we'll set it equal to 0. So anytime we want to know when we have a maximum or a minimum, we take a derivative and we set it equal to 0, because that's where it could turn around. It could have a high point or a low point. So I'll rewrite it when I do this, my derivative, but it'll be 0 equals 0.12 pi r minus 6 over r squared. And I do that to kind of help myself, because I don't like it with the r on the bottom. So I'm going to multiply both sides by r squared, and that will give me 0 equals 0.12 pi r cubed minus 6. Not something I was expecting to get, but let's see what happens here. So we'll kind of work with this. We'll bring the 6 over. So it'll be 6 equals 0.112 pi r cubed. Let's go ahead and clean that up a little bit more, because we want to get r cubed by itself. So we'll divide both sides by 0.12 pi. So r cubed equals 6 over 0.12 pi, which is definitely not a nice number, but we can take the cube root of both sides, and I feel like we're in a good place to use a decimal approximation. So I'll divide that out, and then I'll take the cube root. So I'll take the cube root of what I get. And the answer I get here would be r is approximately 2.52 inches. Okay, so let's go back and find what we needed. It said find the dimensions. So we have the radius, and then over here, when I did my substitution, I have h in terms of r. So let's just use that. We'll say h equals 60 over pi times 2.52 squared. And that's an approximation. So let's just go ahead and put that in the calculator. Oop, I didn't do it right, so let me see if I can fix that. I'll try again. Okay, I'm going to start over. 60 divided by pi, and then divided by 2.52 squared. I'm getting basically 3, but 3.01 inches. So if my math is right, and there's always the possibility that it's not, I'm getting that the radius would be 2.52 inches and the height would be a little bit more than 3 inches to minimize this cost. So that means, based off of the fact that it's 3 cents per square inch to make the top and bottom, 5 cents per square inch to make the sides, these are the dimensions that would require the least amount of material or the least amount of money to guarantee we have a volume of 60 cubic inches. All right. Thank you.